Dear students, let's discuss about carbanions, one type of organic reaction intermediates. Carbanions means carbon will be having three bonds and a pair of electrons. This pair of electrons are given as a negative charge like this. Due to the presence of a pair of electrons, these are actually having a pyramidal structure. The reason for the pyramidal structure is a lone pair of electrons and three bond pairs. So overall the hybridization is sp3, but because of the lone pair the structure is pyramidal in nature. But interestingly, when you go for allyl and benzyl, how allyl will be CH2 double bond CH2 minus. This is allyl carbanion. Benzyl is not due. We'll discuss about benzyl also. I'll tell you about the specialty of this. The allyl will be having a structure like this. This can participate in resonance. So you can have a structure like this. Now, in place of negative charge, now it is having double bond. So this carbon now is planar. So allyl carbanions as well as phenyl carbanions. Benzyl, phenyl group and attached to carbon, that is benzyl carbanion. This will be again due to resonance. It's mostly planar in nature. Actually pyramidal, but these two are very special. They will be in planar nature. Then coming to the remaining points of this. First point is about their magnetic property. Definitely diamagnetic in nature because no unpaired electrons are present. 8 valence electrons are present in their shell. Due to 8 valence electrons, these are very stable like octet configuration. Stable octet configuration is there, but one of the pair is a lone pair of electrons. Because of this lone pair, they are reactive. Electrons number wise they are stable. Having 8 electrons is actually octet stability is there. So you can say such kind of molecules as electron precise molecules, are when negative charge is there, you can say them as electron rich molecules. So electron precise or electron rich molecules are these. So these are diamagnetic, having 8 electrons in the outermost valence shell of the carbon atom. The specialties and the structural aspects we were discussing, this is pyramidal in nature except allyl and benzyl. Now coming to the stabilities of these, CH3 minus is a carbanion, simple carbanion. CH3 CH2 minus ethyl carbanion. Both these are primary carbanions, you can say. CH3 CH3, the second carbon is a secondary carbon. It is isopropyl carbanion. One more will take, if you take all these as methyl groups, this is tertiary butyl, this carbon nature is tertiary carbon. If you consider these, the stability will be primary better than secondary better than tertiary when it comes to carbanions. In carbocations, the order was reverse, but in carbanions, primary is better than secondary better than tertiary. And if you want to give more prior more perfect order, CH3 minus than primary, than secondary, than tertiary. So in one word, you can say stability of carbanions is directly proportional to minus I groups, and stability is inversely proportional to plus I groups. Whatever the inductive effective groups are there, positive inductive effect, methyl, ethyl, propyl, butyl, isopropyl, tertiary butyl, all these are inversely proportional. Lesser the number of groups, the stability will be more. Minus I groups are better. For example, I will look at this. CH2, this is minus charge, NO2. As we know, NO2 is a minus I group, and here actually it is electron withdrawing group. It is going like this, and the charge will come. Because of the shift of the charge here, that means the negative charge is stabilized here, that is converted into a bond. So these kind of groups like NO2, they stabilize the negative ions. So minus I groups are better to stabilize these. Stability factor of the carbanions directly proportional to minus I groups, inversely proportional to plus I groups. Then CH2 minus CH3. Here you see both the carbon atoms are sp3 carbon atoms. CH2 double bond CH minus vinyl type. Both the carbon atoms are sp2. CH triple bond C minus. Both the carbon atoms are sp. sp3, sp2, sp hybridizations. If you see, the S character will be, percentage of S will be here, it is 25 percentage, it is 33.3 percentage, here it will be 50 percentage. More the S character, more will be the close to the nucleus, and higher will be the electronegativity. In general, the electronegativity here we give as 3.29 on Pauling scale. For sp hybridization, this is 2.75 and this is 2.5. So when the electronegativity increases, the tendency of holding the negative charge increases. So sp hybridized groups will be having much better availability or much better chances to hold the negative charge. So CH3, CH2 minus is less stable than CH2, CH minus. This is less stable than CH triple bond C minus. The reason is this is sp3 carbon, this is sp2 carbon, this is sp carbon. Sp carbon more electronegative, can hold the negative charge easily. So this is stable. Coming to CH2 double bond CH, CH2 minus, we were discussing in the initial times only about the structure. Here resonance is there, resonance makes anything stable. So allyl is stable, allyl done. Benzyl is stable because of resonance. Both are good. One interesting factor you can discuss here, that is about the cyclopentadienyl anion. Now here you can see 6 pi electrons are there, 2 here, 2 here and 2 here. Total number of electrons are 6. When 6 electrons are there, and when these are in conjugation, double, single, a pair of electrons single, so they are in conjugation. 6 electrons following Huckel's rule, conjugation is there. Because of this is going to be highly stable. So aromatic carbanions are stable. So all these are important points. Now you can see, if any carbanion having an electron withdrawing group or an atom attached with more electronegative atom by multiple bonds, for example like this, it will be stable because of resonance type of structure. So if any such groups are there, the carbanion is going to be stable. Note these type of things. So finally, what we can say about the stability order: aromatic carbanions stable. After this, Phenyl benzyl type of carbanions are stable, CH2 minus. More the number of these groups, more will be the stability. After this allyl aromatic cyclopentadienyl type, more the number of benzene groups like phenyl groups attached. Here I am mentioning only benzyl. Two benzyl groups, three benzyl groups are much better. Then allyl. After allyl, CH triple bond C minus. After this CH2 double bond CH minus. I hope you remember. If plus charge is there, this was the weakest or the very unstable carbocation. But here it is negative charge, so it is coming here. CH3 CH2 minus. All these are primary. After this you will be getting secondary. After that you will be getting tertiary. This is the stability order of the carbanions. So generally the questions will be about the carbanion stabilities only, where we get these reactions. You can go for aldehydes ketones reactions. Aldehydes ketones reactions, for example, if you are taking a CN minus attacking reaction. Okay, I'll show it again. C double bond O. This is a aldehyde or ketone. This is the attacking reagent, which we call nucleophile. The electron pair is shifting like this. This will be cyanide. This will be O minus. This kind of reactions are called nucleophilic addition reactions. This part is simply added here. Nucleophilic addition reactions. Similarly, you can go for nucleophilic substitution reactions. Have a look at this. Carbon having 3 groups and X. The cyanide minus type of group is attacking from here. This is going out. So what happens here? Carbon 3 groups and they said cyanide is coming, X is out. So X goes with electrons, so X minus, Cn minus forms the bond here. So this kind of reactions are called nucleophilic substitution reactions. The nucleophile is substituting this X group. In the previous case, it is simply adding. So addition reactions. In this case, this is coming and attacking on this carbon. So this type of reactions we can call them as nucleophilic substitution reactions. So this is all about for the carbanions. In carbanions, these type of reactions are generally possible. So we will discuss more about some other ions in next session.